Welcome to the lecture of data science. In this particular video, we will see few topics from the different units. So we will see the application of the logistic regression in the credit rating uh, and the gain chart and lift chart from the logistic regression. So these two topics are from the unit number 6, that is the logistic regression. And at last, we will see one example, that is the calculation based example. From the unit number 2, that is the descriptive analytics. So let's start with the application of the logistic regression in the credit rating. So many credit rating organization use a range of score that is between the two values, that is A and B, called as the credit score, to measure the credit worthiness of a customer. So, a credit scoring model is a tool that is typically used in the decision making process for accepting or rejecting a loan. So, what this application of logistic regression in the credit rating is that in the credit rating system, what they are doing that based on the credit rating, the bank is predicting that whether to give a loan to a particular customer or to not to give a loan. So how to judge that whether they are capable of paying the loan or they are not capable of paying the loan? So they are judging based on the data set of the credit cards. So the topic name is the application of the logistic regression in the credit rating. So, a credit scoring model is a result of a statistical model which is based on the information about the borrower. So, the information in the data set is like this, that is the age, number of loans, etc., like that. So, it allows ones to distinguish between a good and the bad loans. So, it will give an estimate of the probability of default. So, the fact that this model can allocate a rating on the credit quality of a loan implies a certain number of possible applications. So, the aim of the credit scoring model is to perform the classification to distinguish between the good applicants and the bad ones. So, what this credit scoring model in the logistic regression is doing, they are dividing the customers into a list called as the good applicants and into a list called as the bad ones. So, whatever the customer name falls under the good applicants column, so we can the bank can give loan to the good applicants customer because they will pay the loan in future, but the bank has doubt on the customer whose name falls under the bad applicants. So from the data set, how to distinguish the customers into the good one and the bad ones? So the logistic regression is helpful for that, because in the logistic regression, the dependent variable, that is my target variable, is of the discrete quality, that is either yes or no. So over here we want to distinguish at the as the customer will fall under the good ones or the customer will fall under the bad ones. So in practice, this means the statistical models is required to find the separating line distinguishing the two categories in the space of the explanatory variable. So based on the age, salary, education, and etc., what we are doing, we will draw one line which will separate the good applicants and the bad applicants. So what is the difficulty in doing such process? So the difficulty, there are two different difficulties. The first one is that the data is only a sample from the true population. It means we are considering only a particular sample from the complete population. So we have to select a sample in such a way that it is the mixture of the good and the bad applicants. If the population contains 500 good customers and the 500 in the bad ones customers, and if we are selecting a sample which is of a 250 size and that 250 contains all the good applicants, then the logistic regression will not work for such sample. So the first difficulty is how to choose the sample for that, so that the data is only a sample from the true population. So we have to select a sample in such a way that it contains equal amount of the good and the bad applicants. So how to visualize that? Because we initially we don't know that who are the good ones and who are the bad ones. So the selection of the sample is very necessary, which is the first difficulty in doing so. The data is noisy, which means that some of the significant explanatory variables may not have been recorded, or that the default occurred by accident rather than due to the explanatory factors. So, over here, the second difficulty is if noise is present in your data, then the logistic regression will not predict the correct answer. If we talk about the classification problem, then the classification problem is dealing with the missing data and the noising data easily compared to the logistic regression. The logistic regression cannot handle too much noise in the data. So that is the second difficulty. So one of the most common, successful and the transparent ways to do the required binary classification to good and bad is via the logistic function. So this is a function that takes as input the client characteristics and output the probability of default. So you can give the logistic regression formula like this. That is this one as the formula. So what is P? It is the probability of default, where Xi is the explanatory factor I. It means my different attributes in my data set. That is my X attribute. That is my explanatory variable. And beta is my regression coefficient of the explanatory factor I. And N is my number of explanatory variables. So in the credit rating application, you can find out the probability of default, that is the good ones and the bad ones, by using this particular formula. Now let's understand the gain chart and lift chart in the logistic regression model. So we have seen in the classification that how the classification is measured, how it is judged, that whether it is the good decision tree or it is not. So over here in the logistic regression, if you want to measure that how good the logistic regression is, then the gain chart and the lift chart is also useful. So the gain chart and the lift chart are the two measures that are used for measuring the benefits of using the model and are used in the business context such as the target marketing. So what are the benefits of using the logistic regression in my particular data set? So that is told by the gain chart and the lift chart. So the gain chart is like this, that is the cumulative number of positive observations up to the decile I. What is decile? It is the set of 10 observations divided by the total number of positive observations in the data. And the lift is given like this, that is cumulative number of positive observations up to the decile I, that is using LR model. LR model means using the logistic regression model. The cumulative number of positive observations up to decile I based on the random model. So like this, the gain and the lift is calculated based on such type of formula. So what we have to do if you want to calculate the gain chart and the lift chart? So you have to follow this process, that these are the steps. The first step is to split the data into two parts, that is 70% as the training and 30% as the suppose testing data. So they are also calling it as the validation sample. Then what we have to do is a score, that is the predicted probability, the validation sample using the response model under the consideration. So apart from the logistic regression model, you can also make use of this particular response model. Then what we have to do is rank this code file in descending order by estimated probability. So what we have to do, that we have to arrange our data set in such a way that my predicted variable, that is my variable y, will be in the descending order in my data set. After arranging it into a descending order, what we have to do is we have to split the ranked file into the 10 sections. It means what we have arranged in the descending order, we will call it as the ranked file, and then we will split the ranked file into 10 sections, 10 different sections. So that 10 different sections is called as the deciles. So the number of observation in each decile, how many observations are there which falls under each decile. Then the number of actual events which is in the each decile. Then comes the number of cumulative actual events in the each decile. And then comes the percentage of cumulative actual events in each decile. So you have to count the total number of observations in each, then the total number of actual events, it means the total number of positive events in each, and the number of cumulative positive events in each, so that you can uh, put that values in this particular equation, so you will get the answer of the gain and the lift. So you can see over here that is only number of positive observations, it means the actual observations. Cumulative means you have to do the summation of that, like that. So you have to calculate all this, and after that you have to make use of the gain and the lift formula, so you will identify that two particular values. You can also write the steps, that is the gain and the lift chart steps like this also. That is, predict the probability of y equals to 1. It means the positive y using the logistic regression model, and arrange the observation in the decreasing order of the predicted probability. That is, first of all, we want the probability of y equals to 1, and then the lower probability, like that we have to arrange it in a decreasing order. Then divide the data set into deciles, and they calculate the number of positives in each decile and the cumulative number of positives up to a decile, like that. So what is gain? It is the ratio between the cumulative number of positive observations up to a decile to the total number of positive observations in the data. So this is what is called as the gain. And what is lift? Lift is the ratio of the number of positive observations up to decile I using the model to the expected number of positive observations to that decile I based on the random model. So like this, anyway you can write the steps for gain and the lift chart. So whatever the common steps are, that first of all we have to find out the probability for the positive y, then we have to arrange it in an decreasing order, then we have to split the data into deciles, then we have to calculate the number of positive in each decile and the cumulative number of positives. After doing this, we can find out the gain and the lift by putting all the values in the formula. So this is what the gain and the lift chart steps are. Now let's see one mathematical example from the unit number 2, which is given in your technical book. So over here it is written like this, that is, given below is the data of 32 Indian companies for dividend declared during a particular year. So this data has been collected from the textile company from the published sources. So these are the data given. So from the above data you have to find out the average dividend declared, you have to find out the coefficient of the variation and the third and the fourth moments. So this type of example you have already calculated in your mathematics, so it is easy one. So let's see that these are my given data. So these are my given data. Now what I am doing is I am arranging my data into an ascending order. So first of all the minimum value is 0 over here, then 8 is over here, then comes 10. So like that I have arranged my all the value of x. You can see over here that some portion is given in the next page. So how many times the 0 is repeating? This 0 is repeating only one time, so its frequency is 1. How many times 8 is repeating? 8 is 1 over here, and the second time the 8 is over here. So how many times 8 is repeating? It is repeating 2 times. If you take the example of 12, then how many times 12 is repeating? Let's visualize that. That is 1 over here, 2 over here, and 3 over here. So the frequency of 12 is 3. Just ignore this jelly bars. So this is how I can find the xi and the fi. And xi cross fi is like this, that is 8 into 2 is 16, 10 into 1 is 10, 12 into 3 is 36, like that. So I have found out the sigma, that is summation of fi, it means all the fi, and the summation of fi into xi, that is summation of all this in my this particular column, that is fi into xi. Now to find out the average, so what is the formula of the average? That is the summation of fi into xi divided by summation of fi, that is the total number, we can say. So you can put that particular value, that how many total numbers are there, how many total numbers of data points are there, you can calculate individually, or you can directly calculate this frequency number, so that will match with the total number of data points, that is 32 are present. So this is how you can calculate the average, that is the x bar. Now let us follow the table for moments and the CV. So what I have done over here, that the di means the xi minus the average value. So how a particular data point is far from the mean value. So you can calculate it, that is 0 minus 14.28, then 8 minus again 14.28. So like that all the values are there of di. Then you can easily find out fi into di square, fi into di cube, and fi into di raised to 4. So you have to just multiply all this value with the help of calculator, and at last you can find out the summation of all these values. So the standard deviation is given like this, that is square root of sigma of fi di square divided by total number of n. So you have this particular value, that is 496.52, that is the summation. So the formula of standard deviation is like this. Over here, the value is 496.52. You have to write over here 496.52 divided by the total number of n. So you will find the standard deviation. Over here, the values are different, but the formula is same. Coefficient of variation CV, you can also find out with the help of this formula, and you have to put your values based on this particular table. So you will get the answer like this, and the third and the fourth moments also if you want to calculate it. This is also one of the example from the unit number 2, and we have already seen that how this particular example is solved in our lectures. So keeping it till here.